Hi, welcome. This is the network optimization module. The importance of this is the measurement of network performance. It can be measured in terms of how many packets were dropped when transmitting and receiving data. Therefore, you should know how to monitor packet drops. Now, in this module, we'll actually cover some important lessons, network virtualization concepts, as well as monitoring networking I/O activity. In fact, in our first lesson with the network virtualization concepts, we will be describing network virtualization overhead as it relates to virtual machines as the network passes through the ESX server on through the network itself. Also should be able to describe network adapter features that affect performance and network, or I should say vSphere networking features that affect performance. So first things we need to understand here is the network virtualization I/O overhead. There's actually a potential for a lot of I/O virtualization overhead in networking, thinking of as the networking data that needs to be transmitted from, say, an application. If an application has 16 kbytes to send, it's got to first send that through the guest operating system's TCP/IP stack, where each of the different layers of the TCP/IP stack have to process this data. When it hits the TCP layer, for instance, break the 16 kbytes into the frame size of your Ethernet frame. And the IP layer will need to create the IP header, IP diagram, and pass that on to the Ethernet layer. Of course, all of these transmissions from the one layer to the next in the TCP/IP stack of the guest OS is going to incur CPU overhead, virtual CPU overhead, as the guest OS has to process this. Now, can any of that be offloaded onto a network adapter? Yeah, it sure can. In fact, it can be offloaded onto a virtual network if you've got the appropriate type of virtual network adapter, who can then hand that overhead onto the actual physical adapter. But with a straight stock driver that comes with, say, a Windows guest OS or a Linux guest OS, those stock drivers aren't aware of the offloading capabilities, that the fact that these are virtual adapters. So there's a fair amount of overhead in the guest operating system to deal with just the packet processing and then handing that off to the VM kernel as it changes from guest OS address space over to VM kernel address space. There's even some address switching overhead moving from guest OS to VM kernel space. We also have virtual interrupt coalescing, halting and waking up the virtual CPU as the traffic passes through the guest, and then halting and waking up the physical CPU as the traffic is traversing through the virtual I/O stack before it finally actually can be handed off to the physical network adapter. If there's any hardware offloading that could be performed onto that network adapter, there are missed opportunities if the guest is unaware of the fact that it's a virtual machine and could have some para-virtualized virtualization savings here. So, of course, we install VMware tools, and that changes a lot, right? First things is that the driver is aware that it's a virtual driver and that it will actually remove a lot of the overhead as the data traverses from the guest OS over to the VM kernel. There's also a ring buffer that exists between the guest OS and the VM kernel, which also removes a significant amount of overhead. There's also transmission packet coalescing and interrupt coalescing to reduce the overhead on the per packet overhead. There's also TCP checksum calculation to the hardware can be offloaded, right? So normally, if you have a virtual network driver who's got the operations that are happening within the guest operating system, one of the functions of the TCP layer is to do the TCP checksum. That can be handed off to the hardware. With the VMware Tools para-virtualized driver, that can actually be handed off to the real hardware device itself. Same goes with things like TCP segmentation offloading. We'll take a look at that a little bit later. That's actually with a specific para-virtualized driver, not the standard VMXNet driver, though. So keeping that in mind, there's actually several different VMXNet drivers that are possible. There is the standard, the original VMXNet. Whenever you install VMware Tools, this is the driver that is placed in the virtual machine. However, there is an alternative to that. There is one called VMXNet 3, which basically replaced the VMXNet 2. You won't find VMXNet 2 anywhere. That was actually simply an enhanced version of VMXNet, updating the code to support things like TCP segmentation offloading and jumbo frames and 10 gigabit Ethernet. However, the VMXNet 2 was really just, like I said, an extension to the original VMXNet code, thereby preventing it from having a very wide guest support list, where the VMXNet 3 was a complete rewrite from the ground up. So it's all brand new code supporting those same basic features of 10 gig Ethernet and jumbo frames and TCP segmentation offloading, but the VMXnet 3 came out back in the vSphere 4.1 timeframe. So since then, every enhancement for networking has pretty much been put upon VMXnet 3. So all the really powerful features are on VMXnet 3. If there's any adapter you want to use, it's that one. And it has a much wider guest support list. The only thing is that's not the standard, right? When you install VMware Tools, the guest gets the standard VMXnet. You'd have to actually remove that adapter and then replace it with VMXnet 3 to be able to use it. It's pretty common then to make that a standard inside a VM template so that every VM from the master image is going to get VMXnet 3. But there's actually a couple other adapters that are available, right? So here's our standard list. You've got, say, for instance, you install from an operating system from 20 years ago, they might get a VLANs driver, right? Just the stock driver for VLANs. And if you install VMware Tools, it simply gets updated into the VMXnet. If you have a more modern OS from the past 15 years, maybe, you'd have the E1000 driver, or maybe E1000E, an emulated version of that, since that's actually not produced anymore itself, the actual hardware device. So, but that's the stock driver that those guests get when you just install without having VMware Tools. Installing VMware Tools, of course, that gets replaced with VMXnet as well. But like I said, the most common thing anybody would do is install VMware Tools, remove whatever network adapter there was, and then replace it with VMXnet 3. And then we get all the benefits and features of that adapter. And of course, all the enhancements that have been added to that since it was first introduced over 10 years ago. Now there's other ones though. There's the paravirtualized RDMA adapter, the adapter that is aware of the fact that it's going to be an RDMA device passing from guest OS memory all the way through to its destination, bypassing the operating system and reducing a significant amount of overhead. There's also single root IO virtualization pass-through. This is where if the network adapter offers this feature, the guest does get pass-through access right to the device, sharing this with other VMs, select few VMs, but you're able to offset from or offload from the virtual layers of the ESX server and communicate directly to the device. That can improve performance too, but it does lose some major features such as vMotion and high availability and snapshotting and lots of negatives there. But one interesting new feature added in vSphere 7 is now the dynamic direct path capabilities, where you can actually assign path devices to the OS, to the VM with a dynamic nature to support things like vMotion. And that's great. Now, we have a few interesting features that have been added to VMXnet 3 that if you need to improve the throughput of your network adapter, there are actually several interesting characteristics that are available. But you have to keep in mind, a lot of times, as you'll probably notice in all the other adapters or any other hardware devices we've been talking about in this course, we don't really talk about adjusting tunable parameters too often, right? The CPU, the memory, the storage, there's things that we can adjust. But as far as changing tunable parameters, we tend to shy away from that. We don't want to have to make the ESX server favor one type of resource over another, right? The actual raw resources or how a VM uses them. Just have to keep in mind with these interesting networking enhancements, there are potential side effects. This one, for instance, this is what we call VMXnet 3 optimization, to be able to optimize the VMXnet 3 adapter so that the VM is going to improve its overall networking throughput. An option that is available is by essentially turning a VM into a latency sensitive VM, thereby giving a VM a full memory reservation, being able to pre-allocate its memory, not just giving the VM the memory guarantee, but actually already pre-allocating, and essentially as soon as that VM boots up, the memory is granted. When that's done, the networking traffic that needs or the networking IO that needs to pass through the guest can pass through entirely through the VM's memory, improving throughput. Just keep that in mind that, say for instance, we have a VM that's a 512 megabyte VM, but also set it to latency sensitive. Make sure that you have the appropriate settings in the VMX file. Things such as the pre-alloc has been set to true, right? That means we're pre-allocating this memory. It's not just that it's a 512 megabyte reservation. That's this one right here, the sched.mem.min. That means that VM actually has a full memory reservation, but it's not just that it's guaranteed, it's been pinned and pre-allocated so that as soon as that guest OS is booted, it's already got this memory allocated. No need to wait for it to be allocated. It's already there as soon as that guest OS is up online. This gives high priority for networking IO to pass through that VM. And VMXNet3 was designed to handle that. But keep in mind the flip side to this is now the host may be running with less VM to run less VMs because of this. And this is a small VM. It's just got 512 megabytes of memory, but be careful with VMs that are gigabytes in size in fully reserving and pre-allocating the memory in those cases, all in the name of giving the VM highest throughput possible. And if that's a goal, well then yes, that's something that's justifiable, but it's something that you have to consider all sides with. So that's one thing to consider. We have some other interesting ones coming up. So we're going to take a quick break, come back, and we'll take a look at some of the other characteristics and attributes we can adjust with VMXNet3 and other tunable settings. So stay tuned. We'll see you in a few minutes.